In this tutorial, I'm going to demonstrate how to use CityEngine rules to generate landscape forms. This is the first part in a two-part series on rule creation and parametric landscape forms. Prior knowledge in CityEngine is recommended before working through this tutorial on your own, so you might want to check out Esri Canada's other tutorials first. Our Urban Modeling with CityEngine video is a great way to get started and learn the basics of CityEngine. You can also check out some of the tutorials built into the software available through the Help menu. In part 1 of this two-part series, I'm going to show you how to create a simple rule to texture pathways and landscape forms, and we will also work through creating a parametric rule for earth mounds or berms. In part 2, we will cover how to reference rules within another rule to add vegetation, how to generate more organic landforms with other 3D modeling applications, ways to import 3D forms back into CityEngine, and how to set up a scene for rendering or publishing online. So to get started, I've started up a new project here in CityEngine and created a scene. I've imported some data for my base map, and then I've drawn in a couple shapes. And these shapes by no means are realistic to a real site design that I want to be making, but these test shapes are really here purely for the purposes of rule creation. So what I've done here is I've just drawn a couple shapes with the shape creation tools. I've created some arcs, which you can now do in CityEngine. And I've also created a road just going through the park, which is going to become a pathway. So the first thing that I'll do is select the street network that I made, which is just this little road segment. And I'm going to turn off the sidewalks. And the reason why we're doing that is because I'm only going to texture the roadway because that's going to become the paved pathway. So I'll change this to 5 meters wide. And now I'm going to create a rule that textures this in. So I'll right click here to say create new rule, and I'll call this ground. And I'll create a start shape where I color it in just as red, just to see what this looks like. And then I will select my network again and apply the rule. So apply the rule ground and click generate, and you can see now that the pathway is being created in red, which is exactly what we're looking for because we know now that the rule is working. So I downloaded a couple textures, which I'm now going to import into my CityEngine scene, and to do that, all I need to do is click and drag on my textures and drop them into my assets folder here. Say copy files, and my assets are now in the assets folder, so I can use them as textures. And I'm just going to drag in the paver gray ashlar texture. So the way the CityEngine works is when I apply the paver texture to my rule, you can see here, the texture is applied, but it clearly isn't looking right. And the reason for that is because we need to set up the projection and also the UV set. So CityEngine uses 10 different UV sets, which allows us to add in different textures, colors, bump maps, dirt maps, things like that to our textures that we're applying in the scene. And we have to project that texture into the scene. So to do that, what we do is we type in setup projection, and I'm going to use UV set 0, which is my color map, and I'm going to fit it to the scope.xy of my scene and make it the texture 5 meters by 5 meters. And then I'm going to project the UV to layer 0, again being the color map that I referenced in setup projection. So now when I click generate, you'll see that it changes, but it's clearly not looking right. And the reason for that is because we need to align the scope of the shape to the geometry. So to do that, we use a command called align scope to geometry. And all of this can be found in the documentation, in the CGA rule documentation, which is really easy to follow along with. And we're going to say that Z is up. In CityEngine, we typically don't use Y as up, but we use Z as up. And we're going to align it to world.lowest, which is just some of the options that we have when we're setting this up. And now you'll see that the texture is pretty well aligned and set up to the pathway. So you can see that that seamless texture is being applied. The next thing that I want to do is be able to create some texturing off of these shapes that I've generated as well. So I don't want to have to type in different rules and assign different rules to each individual shape. So what I'm rather going to do is to create a case statement that says that when the land type to path, then we will apply this chunk of the rule. And of course, when we type in land type, what that means is that we need to have an attribute that we're creating, in CityEngine, which we'll give as a string value just with 2 double empty quotes. And then we'll say that if the land type is equal to water, then we will apply the water texture, and I'm just going to copy in that exact same chunk of rule, but I will change the texture file from the pavers to the water texture. And we'll say if the case is land type equals grass, then again we'll put in the same texture again as before, and we'll stick in the, say, Bermuda grass. And I'll save this. And of course, in CityEngine, when you type in conditional statements like this, we have to have that else. So I'll say else nothing. So that means that if these are set to anything other than path, water, or grass, then nothing will happen, which is sort of what we want for this rule. So I'll select all of these shapes, and I'm going to assign the rule file, which will just be that initial rule file here. And I'll say generate, and type in that I want this all to be grass, and the parameters on the side here. But for this one, I'll select the road, which is now the path. Oops. And I'll type in that I want this to be path. Looks like I missed some there. So we'll just type in path as well. And then I'll choose one of these and I'll make it water, just to see what that looks like as well. So you can see there now we have a water feature that's sort of just sitting in the land. And again, this is really just for demonstration purposes. It doesn't have to look at all realistic. I'm sure you can all do a much better job at designing a site than I'm doing here. So now what we've got is we've got the land type set up. So we've got a grass texture, we've got the path texture, and we've got a water texture. And I can change the scale of the textures if I want to as well. So for example, here I'm saying that the texture is 5 meters by 5 meters, but I can change it to 6 meters by 6 meters. And we can see there that the texture changes as well. And for the pathways, I can say that this is actually going to be 4 meters by 4 meters. And I'll select that and adjust that as well. And you can see there that those textures are being adjusted. So now that we've got this set up, what I want to do is start to work on generating a berm for some of these shapes. So I'm just going to turn off the background just to get things a little bit cleaner in our scene here. And we're going to work off of one of the shapes, and I'll just keep it really simple right now. So we'll just kind of start with this rectangular shape, and we'll create a new rule file that I'll call berm. And we're going to start to work off of this. So when we start making a rule that's a little bit more complex, it's always good to use an annotation that says start rule in the beginning, which tells CityEngine that our first shape, which I'll call shape, is going to be the start rule that is always going to be used at the beginning when we're applying this rule set. It's just good form to put that in. And I'm just going to extrude this to a value of 20 meters. And I'll assign this onto the rule. So I'm going to change the rule file from ground to now say berm. And you can see that's working now. So we've got an extrusion that's at 20 meters, but it's clearly not a berm. But that's fine because we know now that the rule is working and it's attached properly. And I'm going to, rather than just putting in a value of 20 meters, I'm going to extrude it to a value that I can set. So I'm going to call this max height. I'm just going to make it 10. And I'm going to extrude to the maximum height. So now what this means is on the right-hand side, because I've created an attribute, on the right-hand side now I can type in any value that I want, and the extrusion will adjust accordingly. So now that I've got the basic kind of extrusion going here, what I need to do is work off of this extrusion. So right now this berm is clearly not looking like a berm, but we're extruding the surface up to a maximum height, and this is what's going to become the berm, because what we're going to do is create an offset every time the extrusion occurs until we go inwards more and more and more, and it pretty much becomes like a pyramid form, or depending on the shape, something that's hopefully a little bit more curved. So I'm going to create the extrusion, and then I'm going to say the end resultant shape here is called extrusion. And I'll work off of the extrusion new shape to say that I want there to be an offset, and I'll bring the offset in of 20 centimeters, and the output of that will become offset shape. So now when we run this, you see that the offset is occurring here. I'll make this a little bit bigger just so we can see that actually happening. And you can see the offset is happening, except it's happening on the entire shape, which isn't what we want, because what we rather want is actually just to be offsetting the top piece of the shape that we're going to be working off of. So off of this extrusion here, or off of the original shape that I'm working off of here, I'm going to do what's called a component split. So what we do is we type in comp F, because we're component splitting by the face, and I'm going to say that I want the top face to become the extrusion shape, and that's it. Everything else is going to be deleted. So I'm going to delete this last call to the shape, and I'm going to now just say that the top piece becomes the extrusion shape, and now when I refresh this, I end up with just this piece at the top, and that's all we're going to be working off of, because what we're going to do is kind of create this stacked shape, as I say, and then we're going to kind of smooth it over once we're done. So we've got the extrusion shape and we've got the offset happening here. But now what I want is I only want the inside of the offset, because this border is a little bit useless for what I want. So in the offset here, what I'm going to say is I'm going to specify that I only want the inside. So now when I refresh, you can see I'm only getting the inside. And I'm going to change the attribute also for the offset to be offset value. And I'll make this 0. Let's make it 1 just for simplicity. And we'll make the offset value offset value. And now you can see that's adjusting there. And again, I can change this to something bigger or smaller, depending on what I want the parameter to say. And now what's happening is we're getting this, but we need it to continue to loop, because every time that we're running this rule, what I need to happen is I need this shape to be extruded upwards of a certain amount, of a certain interval, offset by a certain amount, and continue to offset by a certain amount at a continued interval until we reach the top, which is kind of like this pyramid shape that we're creating. So in order to do that, what I have to create is a conditional statement. And that conditional statement acts as a loop in CityEngine. So we're going to say that we need a count, because the count is what's going to be checking to see how many times we're looping through this until we reach the top of the pyramid that we're creating. So I'm going to say here that, and I want a conditional statement. And the conditional statement is going to say that I'm going to take the count, which will be increasing, multiply it by the interval that I want to be moving the shape up by every single time, and stop when I reach that maximum height that I've created. So what this means here is that the interval is something that we have to set as well. So I'll create an attribute called interval, and I'll make this 0.1. Oops. And we'll put an else statement to say that if this isn't occurring, then nothing will happen. So what's happening here is that we're running this conditional statement saying that as long as the extrusion isn't at that maximum height value, continue to run this chunk of code. And this chunk of code is saying that if we're going to extrude to the maximum height, and then we're going to do a component split at the top, and we're going to change and increase the count by saying set count plus 1. Say then actually I think what I want to do is rather than extrude it to the maximum height, I'm going to extrude it to the interval height. Something's not happy here because I didn't add the colon in the case statement. So now when I run this, you can see we've got the small interval now increasing to 0.1. And ideally what should be happening is this should continue to occur with the extrusion until we reach that maximum height value. But we're not getting a loop because this is just a case statement that runs once and then it moves on to extrusion and never runs again. So what we need to do is to create that loop, we need to call the shape rule or shape piece from the extrusion piece again. So what that's going to look like is we're going to say that we want to create the offset to the offset value like we created here. And instead of creating an offset shape, or actually we'll keep the offset shape, but we're going to call the shape again, that original shape, so that we loop back into this. So when I run this now, we end up with something that is looping over and over again by a certain interval, by a certain height, until we get to something that really isn't looking very good. But it is working because what's happening now is we're getting the interval increasing by 0.1, and I can change that to something larger. And we're getting the offset value to be a certain amount. And we're getting the maximum height to be, in this case, 10, but we can reduce that to 5 or even lower so that this actually starts to look kind of normal. I'll increase that. And now we're getting something that's looking a little bit more like a berm. So this is great and all, except this clearly isn't really looking like a berm yet. We've just got some stacked shapes. So what we need to do is actually start to model out what those edge conditions are going to look like and slope them inwards to create that kind of enclosed form. So this offset shape that I've made, we can see what's happening here. By just applying a color. It's just creating a replica of the offset shape that I've generated, and it's coloring it in right now as red. So what I want to do is create another offset by the same offset value that I created before. So you can see that's what's happening here. And I'm going to use this piece here that you're seeing to be angled down, and that's going to become what encloses this form. So here what we can see is we're creating that offset value, and then I want to split it again with a component split, except instead of creating just the top face that I'm splitting by, I'm going to take the border shape and I'm going to call this roof, or I'll call this edge. And I'm going to take the inside shape and I'm going to call that, I don't know, we'll call that the inside berm. If we take the edge shape now, we apply a color, you see that that's turning kind of like a purple color there, and we take the inside berm make that another color, and you can see that that's kind of becoming like that blue color. So we're able to isolate the outside piece of each layer and then the inside piece, which is exactly what we want happening here. So with this outside piece, this kind of edge that we've made here, I need to create a sloped angle. And the best way to do this that I found in CityEngine is to use a roof command, because CityEngine is really great at creating architectural pieces, but it's not always the best in creating these more organic forms. But if we use the roof shed command here, and I'll just set this to just a certain value, and I run this, you can see that we get this sloping that's happening, which is kind of close to this curvature that we want forming in a berm. And the more that I adjust that value, the more extreme of that angle we can get. So you can see that's a little bit too extreme, but the way that we can calculate a perfect angle to enclose our shape so that it's kind of this seamless texture going between each level of the berm is by figuring out what that angle is. And so in order to do that, what I need to create is a calculation here that finds the inverse tangent of the interval that we're using divided by the offset value that we're using. So when I run this now, you'll see that we get this really cool enclosure around the entire shape, except for at the top, and we'll address that in a second. So now what this means is that if I'm now changing the interval or offset values, the roof shed angle should be adjusting dynamically as well. So you can see there if I increase and decrease that, it's changing the offset value. I can make something really shallow, or I can make it really extreme. And again, we'll address this in a second. But you can see that that angle is changing dynamically, which is exactly what we want. So let's bring it back to what we had before, where you can see now that the top of the berm isn't exactly working properly because we are addressing it and we're finding it in that kind of top blue piece, but it's not at the top as we want it to be. It's kind of set down. So again, what we want to do is create a conditional statement. And this time that conditional statement is going to say, base it off of the count again. So we're going to use that same count times interval statement, less than max height. And if the count is less than the maximum height, then we're going to do exactly what we just did before. But if it's not, then we're going to do inside berm. Oops, and I'll paste that in there. And now when I run this, I did something wrong. There we go. Now when I run this, you can see that the inside berm now is this kind of solid blue again, which is exactly what we're looking for because now we've capped the berm pretty much to the top piece. So this is great and all, except now what we need to do is actually start to texture this up. But before we do that, I just realized here, we're seeing that outside border that's happening when we do the offset. And that's because the case statement is actually happening a little bit too late. So what we need to do is move that to the rule or the shape that's being created just before we call edge. I'll take that. Now we'll run this and you'll see that now we've addressed this before we get to that offset so that we always create that clean output. So now all we have to do is actually start to texture this up. So the inside color that we've got here, which is this, right now we just got this dark blue, we need to texture it with whatever we want the berm to be textured with. So I'm going to texture that with the same texture as I had for the grass. And I'm just going to copy this exact same chunk of rule into here and apply this to my shape. And you can see that's looking pretty decent. And now we need to apply that same texture to the sides here. So this here, again, we're going to get rid of that color and paste that in. And you see here it's turning red again, which means that what we're doing is we're actually somehow calling this red value in again. So when I refresh that, you see that the texture is not being brought in properly, which is fine because what we need to do is create another shape rather than using this within the same shape. So we'll create the roof shed and then we'll create slope color shape. And then I'll call the slope color shape with that texture that we used before. And now when I refresh this, it will apply that grass texture on. So let's see what happens now if we start to apply this rule to some other forms that we've got here. So again, I'm going to change the rule here from ground. Actually, I'll choose a couple of these shapes just to see what's happening. So we'll change the rule here from ground and we'll apply this to be a berm. And you can see again, it's clearly not working so well here because the interval and the way that this is being set up is not working so well for what we've got predefined here. So I'm going to change the interval to be 0.1. The maximum height will be 10 and the offset value will be 0.5. I'll bring this down to 4.5. So make it even less. So we've got there. And this one as well, we can bring this up to say the interval will be higher in this one. We'll make this 0.5 actually, and we'll bring the maximum height down to 5. We'll do 4.5. So it is a bit of manual work to set up each of these berms because you can just keep adjusting it, but that's one of the nice things about having parameters is that we can adjust that really quickly on the right hand side, and there's a way that we can actually do that even faster, which we'll look at in a second. Say 3. So we've got these pieces here. So if we want to do this a little bit faster, what we can do is we can start to add in ranges at the top for these values. So instead of just having maximum height as a default value where we have to manually enter in the next value that we want to be using, we can just say range equals minimum, and minimum equals 0, max equals 10. We can do the same thing for the offset value, which we can make as that, and count we actually want to hide because that's just something that's happening in the background. And again, the interval there we're going to make as 0.1 and again as 10. So now when I save this, I can adjust the sliders here and you can see how quickly we can start to play around with the different shapes and forms. So here I can change the maximum height and the offset value to be something that's higher. I can change the height then, and then the interval, and you can create some interesting forms. So let's turn off the wireframes and see what's going on because it doesn't look like the grass is right. And so the way that we can fix this is by changing the scope, because just like we had to do with the align scope to geometry for the top piece, we have to do the same sort of thing for the sides, and CityEngine doesn't like to apply the texture onto the side angles when it's a sloped angle like this. And so what we rather want to do is instead of assigning the projection to scope.xy, we want to do world.xz. Oops, that was the wrong one, but that's okay. We can apply that on the top there as well. And now when we apply this to these shapes, see that it starts to look seamless. So now if we turn our terrain back on and we turn off our shapes layer, you can see now we've got some pretty interesting looking berms. I'll just refresh these all to refresh the textures. And there we go. Now we've got some berms in our scene that we can start to play around with. We can move it up and down to have them sink into the ground a little bit more if we want. We can change this over here to be grass if we want it instead of water. And now if you go down to that street view here, you can see you've got some interesting looking shapes that we can start to play around with. And that's how you make a berm in CityEngine with the rules. In the next tutorial, we're going to be looking at ways that we can start to modify this and smooth this out a little bit more, because you can see that it is still some hard angles in some of these areas. And we'll also look at ways that we can start to render this a little bit better in CityEngine.